Well, hi there. This video is going to take a look at comparing and ordering numbers that are in scientific notation, and the second part of the video will take a look at operations with numbers in scientific notation. So let's get started. The first thing we're going to do is compare numbers in scientific notation. And if you really think about numbers that are written in scientific notation, the first thing we really have to look at is the power of 10. In number 1, I have two examples. The first one, 7.0 times 10 to the 11th compared to 8.4 by 10 to the 12th. Well, 10 to the 12th is obviously a larger number than 10 to the 11th. Likewise, if I look at 3.5 times 10 to the negative 6, that has fewer decimal places than 7.9 times 10 to the negative 7th. So this is going to be larger than this. If the two numbers in scientific notation have the same power of 10, then we just need to look at the coefficients, or the first factors. So our first example in number 2, they are both 10 to the power of 8, so 6.2 is larger than 3.0. Likewise with the second one, they both have the same power of 10, so all I need to do is compare the 7.9 to the 3.5. Now I'd like you to do 1 through 4 in the practice problems and come back and check your answers. Okay, so the answers to the practice questions are up there. If you have any questions on these, please mark them down and we'll go over them tomorrow. The next thing we're going to do is order numbers in scientific notation, which is basically like comparing over and over again. First, we have to compare the powers of 10 and then compare decimals. However, if they are not in scientific notation to start with, which is the case in the example here, the first step is to write them in scientific notation. So I need to convert each of the numbers into proper scientific notation, which has been done for you, and then I would order them, and then I actually have to rewrite the original number in order. So this would be my final answer. I have a couple of examples here for you to look at on your own. This is not in your notes, so I'd like you to just pause the video on this slide and take a look at the numbers, rewrite them in scientific notation, order them, and then rewrite them in the original format. So pause here and write these down on a piece of scrap paper. Okay, we have rewritten in scientific notation, then I ordered them, and then I rewrote them in the original format. The second problem, the numbers are rewritten in proper scientific notation, and then they are rewritten in the format that they were given to me. Let's move on and talk about operations with numbers in scientific notation. So we are going to take a look at all 4 operations: addition, subtraction, multiplication, and division. And if you could just take a look at the first example in your notes and read through that. Could cancel some zeros like it says, and I would cancel 4 zeros here with 4 zeros here. And if I divided 13,000 by 53, I would get about 245 babies born per minute. Now I want to take a look at this problem in scientific notation. So take a moment to stop and write that problem in scientific notation. It's 1.3 times 10 to the 8th divided by 5.3 times 10 to the 5th. So if I wanted to do this computation in scientific notation, the way it would work is I would just divide the 1.3 by the 5.3. Those of you who are not well versed in your decimal division might want to take this and practice it. So by dividing the decimals, I get 0.245. Subtracting the exponents, I get 10 to the 3rd. And then when I put that into proper scientific notation, I'm making this bigger by 1, so I make that smaller by 1, and my final answer would be 2.45 times 10 to the 2nd, which in fact is the same thing I got when I divided it with all those zeros. Let's look at the steps for multiplying and dividing numbers in scientific notation. The first step says use the number properties to reorder and regroup the factors. Unfortunately, we don't know what those number properties are. You might know some of them. The ones we're concerned with here are associative and commutative properties, but if If that does not sound familiar to you, we will be doing that in our next unit, so you can look forward to that. We multiply and divide the decimals, then use the rules of exponents to multiply or divide the powers of 10, and combine, rewriting always our final answer in proper scientific notation. Looking at the first example, I would multiply 4.7 by 2.9. Now, many of you should still be doing this longhand because your decimal operations are not as polished as they should be. However, I'm going to give this one to you because I want to just show it as an example. So that would be 13.63 times 10 to the, add the exponents, 14th. However, this number is not yet in proper scientific notation, so I need to rewrite it for my final answer. 1.363, made that smaller by a place value of 10, so I make that larger by a place value of 10. Pretty straightforward. Division is a similar process, so I would divide 1.5 by 7.5, remembering that this is our process for dividing decimals, and 75 goes into 152 times. So I get 0.2 times 10 to the, subtract the exponents, negative 13th. I have to make this larger by a power of 10, so I make negative 13 smaller by a power of 10, which is actually negative 14. Final answer. Okay, so I think you can probably pause here and work out 3, 4, 5, and 6 on your own. Come back and check with me when you're all done. Alrighty, so I have the answers here. Hopefully this gave you a chance to work on some of your decimal operations as well as scientific notation. Now notice that I did not put any of these numbers into standard form, nor should I, because if I give you a number in scientific notation asking you to compute the product, quotient, sum, or difference, you should be using the numbers in scientific notation, and you will lose points if you put them into standard form in order to do so. Now, let's go on to addition and subtraction of numbers in scientific notation. And I've said it before and I'll say it again. Adding and subtracting is much harder in math than multiplying and dividing. So what we need to do here is, first of all, I need to rewrite all the numbers so they have the same power of 10. So some numbers will not be in scientific notation any longer. Then I add and subtract the coefficients and rewrite the sum or difference proper scientific notation. The first one is pretty straightforward because they have the same power of 10. So if you think about that, that's basically saying they have the same power of 10, so my decimal points line up. If I add 5.7 and 9.2, it's 14.9 times 10 to the 4th. Again, not in proper scientific notation, so it becomes 1.49 times 10 to the 5th. The next question is not in the same power of 10. So what I want to do is I'd like to make them the same power of 10. Usually we'll go to the larger power of 10 because it will make it easier in the long run. You will not have to simplify as often. So I'm going to change the 7.2 to 0.072 times 10 to the 12th. How did I know how many places to move that? Well, I looked at the 12, knew that I had to make the 10 into a 12, which means I have to make it bigger by 2, so I have to make my coefficients decimal place smaller by 2. Then I can go ahead and add the 3.5 to the 0.072, giving me 3.572, and then my final answer is going to be 3.572 times 10 to the 12th. Let's try one more, and then I will let you work on your own. So in number 3, the second number is not in scientific notation, so we're going to put it into scientific notation. That's 4.2 times 10 to the 5th. But my exponents don't agree. So I want to make the 5th into a larger exponent by 3 decimal places, which means I need to move my decimal on the 4.2, 3 decimal places. This number becomes 0.0042 times 10 to the 8th. Then I can go ahead, I can add my coefficients, and I get 3.9512 times 10 to the 8th. Why don't you pause here and complete the remainder of the page? There are a couple of word problems. Go ahead and tackle those and come back and check your answers. Welcome back. Here are the answers to questions 4 through 8. So 4, 5, and 6 were pretty straightforward, other than the fact that they were subtraction and not addition. Hopefully you caught that. And 7 was a little more challenging than 8. 8 should have been pretty straightforward. 7 was a division problem, and you should have put those numbers into scientific notation. If you didn't, you might want to pause here and try it again with the numbers in scientific notation and see if you get the same answer. I converted both numbers to scientific notation and decided that this was a division problem. When I divided 9.3 by 1.86, it worked out quite nicely, and I got 5. By subtracting my powers of 10, I got 2. That's actually exactly 500 seconds. Then to convert my seconds into minutes, I divided 500 seconds by 60 seconds per minute and got 8 1/3 minutes. We will do a lot more with word problems and computation in scientific notation in our next class. Until then, have a wonderful afternoon or evening, and I will see you all next time.